I became department head in July of 2015, and at the time of this recording, it's not been a full year yet, so it's been a wonderful year of discovery with respect to the excitement and enthusiasm of the members of the department in chemical engineering. In chemical engineering, there are several exciting things that are going on right now, and we've been having a long-range planning process to talk about where we want to be in the future. Right now, we're very interested in being able to teach our undergraduates the importance of chemical engineering. There are a number of faculty who are working on very exciting areas, not just in biomedicine and biomedical engineering, but in energy, in electronics and displays, in the environment, and looking at a range of different energy applications. So we want to convey the excitement of what our faculty do in our classrooms. And what we are hearing from our undergraduates is that they would like to have an opportunity to put their hands on chemical engineering at an earlier stage. So we're actually looking at how we can incorporate more hands-on learning opportunities for our undergraduates so that they have a better understanding of how the world works from the chemical engineering perspective. And they also have an idea that they can build something that can be very meaningful. We will also be introducing examples of the kinds of things that chemical engineers do now in our classes as they move along from sophomore to junior to senior year. So I think there's going to be a lot of exciting renaissance in terms of our teaching efforts in the department. On the other hand, looking toward the future, we're very excited about the fact that chemical engineers are everywhere, and there are very large opportunities for chemical engineering in the future. In our long-range planning process, we've been talking about a number of these areas. We already have a very huge presence in energy, but we think that there are some new areas, especially based around new catalytic capabilities, which will allow us to be much more effective in the generation of, for example, biofuels, and much more effective in environmental remediation, in carbon dioxide sequestration, and a range of other applications in which we can impact the health of the planet by creating alternative fuel sources or by addressing carbon dioxide. Now, there are other areas that are very exciting as well, and these include the development of biopharma. Biotechnology was really developed and at its core in the chemical engineering department. Charlie Cooney and Danny Wan, big giants in the biotech world, helped to found what we see here in Kendall Square, along with a number of other colleagues at MIT. In chemical engineering, we believe that this biopharma trend is actually going to continue with some interesting new emphases. We have an effort right now in our department that looks at continuous manufacturing, which is the idea of having a development of a product and the generation of a product in large scale that is continuous rather than in single pots, which is what we do now. And this would actually enable a larger production of these pharmaceuticals, making them much more broadly available and much more consistently made. On the other hand, there's also the need for what we consider personalized medicine. And in this category, the idea of generating specific molecules, proteins, DNA, siRNA, on the scale that is appropriate to address patients in a certain subcategory, sometimes very specific, requires a very agile kind of manufacturing approach. And some of our professors are now looking at ways to address this kind of precision manufacturing on a larger scale. So I think that there are some interesting problems in that area that will allow us to further extend our reach. In the meantime, I think that there are some very important new problems that we're going to be dealing with, including the use of membranes and other separation applications to address water. One of the biggest areas and biggest challenges that I think the world is going to face as we have to deal more and more with the recovery of water from seawater, for example. More ways of addressing how to get potable water. I think there are also some interesting problems with air pollution, and I think we're going to be engaging more in that. And there's also some very exciting things going on in the nanoscale fabrication applications. And to address these kinds of nanotechnologies and bring them to the larger world, we have to learn how to manufacture them in a sustainable fashion. This means that there are a large number of new chemical engineering problems that can be solved, looking at nanofabrication and the generation of material systems on the large scale while maintaining their quality and their efficacy.